Welcome to Eco Driving, a short class that will help you drive green, which will save you green. This course has been developed by the North Carolina Clean Energy Technology Center at NC State University's College of Engineering. Funding was in part provided by the North Carolina Department of Transportation with federal funds as part of the Clean Energy Technology Center's Clean Fuel Advanced Technology Project. In this short video, we are going to cover the fundamentals of eco driving, including what eco driving is, why do it, and driver practices. So what is eco driving? Eco driving is smarter, more fuel efficient driving through modified driving habits and vehicle treatment, use, and selection. Fundamentals of eco driving are easy and straightforward. In fact, most of us already know many of the fundamentals of eco driving. However, consistently practicing eco driving and achieving results requires that it becomes a habit. This requires making it a mindset and a priority every time you get behind the wheel. Just like getting better at a sport or activity or getting in a better shape, most of us know what it takes, but we need to have discipline and consistently apply the practices to the point where they become habits. Why practice eco driving? It is typical for an eco driver to achieve between a 5 and 33% improvement in fuel economy. Why is that important? At the macro level, there is energy security in the U.S. economy. U.S. appetite for oil relies on foreign sources for approximately 40% of our needs. Depending on the price of crude oil, this translates to somewhere between $750 million to $1.4 billion a day that leaves the U.S. economy. By driving more efficiently, you can help reduce the U.S. demand for foreign oil, thus reducing our foreign dependency and keeping dollars here in the U.S. economy. Using statistics from the U.S. DOT and the Energy Information Administration, if all on-road vehicles increase their average fuel economy by just 1 mile per gallon, that would save more than 10 billion gallons of fuel per year. From the micro perspective, you and your organization can save money by reducing your fuel bill. In addition, the practices of eco driving have shown increased safety. On both the micro and macro level, eco driving and its reduced fuel consumption results in reduced emissions, which have both health and environmental benefits. Studies have linked health risks and complications to transportation-related emissions. These effects, some of which include premature death, include the worsening of existing heart and lung conditions such as asthma and increased incidence of heart attacks. I mentioned safety as one of the reasons to eco drive. The techniques and practices of eco driving involve less aggressive driving techniques, which leads to increased safety as well as reduced stress. Companies that have instituted eco driving programs have reported up to a 20% increase in miles driven per accident and a 25 to 35% reduction in the number of reported accidents. This will further contribute to savings and increased productivity for an organization. Now we will go into the how of eco driving. This is an abbreviated version of a longer course. We're going to focus on driver practices. Different drivers of the same vehicle can achieve very different fuel economy results because of the way they drive. In addition to driver practices, the longer course includes procedures, which covers vehicle use and maintenance, and equipment, which covers vehicle selection. So starting with practices, here's a summary of the habits that drivers can employ to save fuel and money. Reduce your speed. Practice consistent and anticipatory driving. Proper gear selection, which primarily applies to manual transmission vehicles. For automatic transmissions, it is throttle position. This throttle position influences your shift points. The issue here is to keep your RPMs down. Coast when it is safe to do so, and avoid idling. We will go into more detail for each practice in the following. Most of us know that as speed increases, fuel economy decreases. This is because the drag force is proportional to velocity squared, which means the force required to move a vehicle and maintain speed increases faster as speed increases. Note that the slope of the drag versus speed curve gets steeper as speed increases on the plot of drag force versus speed. For most vehicles, the sweet spot for fuel economy is between 45 and 60 miles an hour. At around 40 miles an hour, the torque converter locks and there's no slippage loss in the transmission. Then you move into the power band of your engine where the powertrain is most efficient in that 45 to 60 mile an hour range. A simple rule of thumb regarding fuel economy loss and increased speed is that for every 5 miles an hour over 60, fuel economy decreases by 7 to 10%. The lesson here is to slow down An example of reducing speed to achieve better fuel economy is in the trucking industry. Some of the companies have governed their trucks at certain speeds and are paying drivers higher rates the lower they allow their trucks to be governed at. This results in a win-win for both sides: lower fuel costs for the company and higher pay for the drivers. Here are on-road results using a scan gauge tool for a GMC Envoy with a 4.2 inline six. This is with cruise control on, traveling the same stretch of road at 55 miles an hour and then at 75 miles an hour. At 75 miles an hour, the fuel economy was approximately 25% lower than at 55 miles an hour. The next speed-related driver practice involves anticipatory driving and driving consistency. When driving, you want to try to achieve smooth, steady driving, which is more fuel efficient than driving at speeds with extreme variations that might have the same average. When traveling on a highway that does not have steep grades, cruise control can help. Highway tests conducted by Edmunds showed a 7% average increase in fuel economy with cruise control. Also, avoid quick, wide open throttle or jackrabbit starts and hard braking. An automatic transmission's shift points are determined by throttle position. Therefore, with more throttle, the shift points will be at higher RPMs, which is less fuel efficient. With a manual transmission, keep RPMs low and shift into higher gears as soon as possible without lugging. Try to anticipate and prepare for slowing and stops by coasting and gradual braking instead of accelerating and braking hard. When braking, energy is wasted by turning the kinetic energy of the vehicle into heat.
This is a demonstration of an easy stop. This is a demonstration of a hard stop. This is the easy, off-the-line start. This is an aggressive, off-the-line start.
So look at the difference more carefully. Here's a static picture of the results for easy, moderate, and hard acceleration off the line to approximately 45 miles an hour. For the easy off the line, the throttle position is approximately 30%, RPMs are below 2,000, and fuel economy is 12 miles per gallon. For the aggressive off the line, throttle position is 87%, basically wide open throttle, RPMs are over 5,000, and fuel economy is 1.9 miles per gallon. With increased throttle position or more aggressive starting off the line, RPMs are higher and fuel economy is lower. Calculating the cost to drive 100 yards in these conditions, it costs between a nickel and a dime for that aggressive start. Over time, that can really add up. Continuing with anticipatory and consistent driving. Keep a safe distance between you and the traffic in front of you, always paying attention to what is coming ahead. You want to give yourself options to be able to act instead of react. Reacting means just slamming on the brakes. In highway situations, if the traffic ahead slows with adequate room, you can coast and maybe not have to hit the brakes or have the room and time to go around the congestion. You also want to look ahead to anticipate traffic signals, intersections, and stops to avoid hard braking or aggressive maneuvers. When on surface roads, select your lane to maintain flow. With two lanes traveling in the same direction, typically there will be vehicles in the right lane that are turning or entering. If you are following, it will likely require almost coming to a complete stop and then accelerating to catch back up to the flow of traffic. If there's not a turn lane to the left, the same can occur in the left lane. Also, when on the highway, move over to the left to not have to slow because of traffic entering from on-ramps. In some areas, the traffic lights are timed. Try to travel at a speed where you do not have to stop. It takes significantly more energy to start from a complete stop than to accelerate if you are moving, a consequence of Newton's first law of inertia, the natural tendency of an object at rest to stay at rest, and the tendency of an object in motion to stay in motion unless acted on by an outside force. In areas that you commonly travel, you should be able to determine and take advantage of the timing of traffic signals. Remember at all times to take safety into account. To reiterate, avoid aggressive driving and tailgating. It saves on fuel, is safer, and reduces stress.
This is an example of following too close. This is an example of following with enough distance to change lanes. This is an example of traveling in the free flow lane.
When you're idling, your fuel economy is zero. It is something that should be avoided. Because today's modern vehicles have many sensors and controls, most vehicles do not need to idle at initial startup. Cold weather near zero might require 30 seconds, and extreme cold below zero might require up to 3 minutes. This is to warm up engine oil to ensure proper lubrication. Till the engine is up to temperature, the engine control systems operate open loop, dumping more fuel than required. Therefore, it is best to drive at a moderate speed to achieve a quicker, more efficient warm-up. After warm-up and when in operation, it is best to turn your vehicle off if you're going to sit idling for more than 30 seconds. On light and medium-duty gasoline vehicles, the equivalent idle time to starting or restarting is 10 seconds. However, to offset increased maintenance costs to the battery and starter, break even is 30 seconds. For medium-duty and heavy-duty diesel vehicles, unless there is a need for turbo cool-down, the engine startup or restart equivalent is 30 seconds idling. Another way to look at idling is that idling your vehicle for 2 minutes, which is easy to do, uses the equivalent of a mile's worth of fuel without going anywhere. Further reasons not to idle include increased wear to engine, ignition, and exhaust components, and incomplete fuel combustion, which wastes fuel and causes increased emissions. An item that is not really a driving practice, but I do want to emphasize here, is not to ignore the check or service engine telltale. Today's vehicles have a number of electronic controls and sensors to keep them running optimally. These onboard diagnostics will keep your vehicle running even when things are not right. Fortunately, when the system detects an error, it throws a trouble code that is stored in the vehicle computer, and the check or service engine light illuminates on the instrument panel. This is an indication that something is not working right and could be serious. Some common problems that will throw a code are O2 sensors, a loose gas cap, evaporative emissions leaks, a misfire, catalytic converter issues, or a thermostat problem. Any of these problems can significantly degrade fuel economy. A bad O2 sensor or thermostat problem can reduce fuel economy by 25 to 30%. So again, do not ignore the check engine telltale. The techniques discussed so far do apply to electric vehicles and hybrids. However, before we finish, I do want to include a few pointers specific to these vehicles. For both EVs and hybrids, fuel efficiency monitoring is very easy with their video game-like displays. This continuous driver feedback helps maximize efficiency. One of the big benefits to hybrid vehicles is a higher average fuel economy than conventional counterparts, which can be further increased with proper driving techniques. While driving at higher speeds, you will want to employ the pulse and glide technique to maintain speed. This allows you to make the most use of the electric motor. Some hybrids allow you the option of selecting EV mode while driving, which forces the gas engine to stay off, a useful option for short trips. Braking should be quick and light, allowing for greater battery recharging. Hard braking uses the mechanical brakes generating heat instead of electricity. As with conventional vehicles, use of the correct grade of engine oil is important. With the smaller engines and hybrids, it is even more important. To maximize range and miles traveled using electric power, charge whenever you have the opportunity. As with conventional vehicles, accessories use energy, and this is more significant with EVs and hybrids. One trick that can help conserve charge is cooling the cabin while plugged in before starting a trip. You should note that because hybrids have a higher base fuel economy, there is even greater opportunity for eco-driving savings. A 20% improvement from a starting point of 50 miles per gallon is an extra 10 miles per gallon, where a 20% improvement on a conventional vehicle, say with 28 per mile gallon average, yields an increase of 5.5 miles per gallon. Here is a summary of the points that we have covered for eco-driving. Keep your speed down. Easy starts and stops with attention to RPMs. At any speed, higher RPMs burn more fuel. Coast when possible. Avoid idling. Practice anticipatory driving with consistent speed. Do not ignore telltale indicators. A good measure is to keep track of fuel economy on an ongoing basis. How do you know how you're doing if you don't keep score? At a minimum, log mileage, fuel used, and fuel cost at each fill-up. It is better if you can do it daily via trip computer, scan gauge, or data logger. When you see your results, try to remember and note conditions or actions that contributed to good fuel economy or poor fuel economy. It might also be good to calculate and track how much money you saved or wasted. This will provide reinforcement or help you learn to be more disciplined to achieve better fuel economy. Also, remember that the little things add up. A 2% improvement 10 times is a 22% improvement, or saving that nickel every time you start from a stop adds up over the course of years of driving. Thank you for taking the time to complete this class. I hope that you have found it useful and will practice eco-driving to save fuel, which will reduce your emissions and save money, as well as increase safety. If you would like more information on clean transportation and clean transportation technologies, the North Carolina Clean Energy Technology Center's Clean Transportation Program is your resource. Please visit our website or contact us. We are here to provide information and assistance.